In order to graph one period of a secant function, I'm going to follow a very similar process to what we did when we graphed a cosecant function. So hopefully you're somewhat familiar with that process if you've watched the other videos. It's going to begin by actually graphing the reciprocal function. So the reciprocal of secant is cosine. So I'm going to begin this problem by graphing 5 times the cosine of 1/4 x. And it's going to be a very, very similar process, like I said, to cosecant, with one little tiny difference at the end. So the amplitude of the cosine function would be 5. The secant function has no amplitude, but the cosine function has an amplitude of 5. The period then would be 2 pi divided by the b value. So 2 pi divided by 1/4 would get me 8 pi for the period. And then I note there's no reflection going on this time because the a is positive. There's no vertical shift because there's no number being added or subtracted at the end. So that's really all I need to get this graph. So once again, I'll start as we've always done by graphing the cosine wave. So let me get the period labeled on my x-axis. So I'll start from 0. It's going to go all the way out to 8 pi. I'm going to need the middle point at 4 pi. And then I'll need, oops, that's a terrible pi symbol. I'll need halfway, or quarter of the way, half of halfway, which would be 2 pi right here. And then finally 6 pi right there if I complete that. So those are the points I want to look for. Again, there's been no shifting up and down, so I should be ready to add in my points. Oops, I forgot one thing. Make sure I get my y-axis labeled here with my amplitude. So 5 and -5 would be the high and low points of that graph. So now I'm going to go ahead and get my cosine graphed. Remember, cosine begins from the high point, so at 5. From there, it's going to drop down to the midline. Third point would be then at the low end, back to the midline, and then we'll stop where we started back up high. So remember that cosine, though, kind of curls at the end. So when I go to graph my cosine function, I'm going to start it a little behind, and then I'll drop down through here. Notice I'm doing this as a dashed function because the cosine's not really the function I care about. It's reciprocal that I'm going to want to eventually see, and I'll curl this back down at the end. Okay, I said there's one little tiny difference between how we did a cosecant and how we're going to do a secant, and that is I want to add one more point on my x-axis. It'll just be the reflection of this point over here. So -2 pi. And then I want my cosine wave to continue through that point. And here's why I wanted to do that. As we talked about in the previous videos with the cosecant functions, every time that graph hits the midline, or in this case the x-axis, there'll be a vertical asymptote formed. So right here at 2 pi, there's a vertical asymptote because that y value is 0 and the reciprocal of 0 is undefined. So there's an asymptote here at 6 pi, and if that's all I used, I'd have 2 asymptotes, and I wouldn't get a full view of one complete cycle, one complete period of this graph. So that's why I added this third point back here. We could have just as easily added it over here at this end, but I decided to move backwards for it. And so by doing that, now I have 3 vertical asymptotes, which I'll be able to see 2 complete cycles of the cosine, or the secant wave. So just like with cosecant, my wave is going to be a series of u's where the low point of the u matches up to the high point of the cosine wave. So 0,5 is a point on both. And notice it's trapped between those vertical asymptotes. And then I'll repeat that process. So there'll be another cycle, another part of the wave down here. Those two together make one complete cycle. 2 of the u's together make one period. And again, that point is shared by both the cosine and the secant wave. And so there's one complete period because I have the 2 u's in there. However, you can see that there's kind of the start of another period over here. So if I want to begin the next u, it would start like that and then repeat forever. So I'm just going to stop there because otherwise I'd be drawing a bunch of u's forever. But there is one complete cycle of this, or one complete period of this graph with a little extra bonus here at the end.